Okay, so question one. During fifth period lunch, 85 of the 280 students had milk as their drink. Based on those results, how many of the 1,390 students at school would drink milk? So we did a little experiment, and we took a small sample of the students, and 85 out of 280 said they will drink milk. We're going to take that and multiply it by the larger group and see and make a prediction here, right? So we can do 85 over 280 times 1,309, and we get about, so the final answer is 421 and 27 over 28 students. Obviously, we can have students in the fractional format, so it'd be 422 students. A bag of marbles, blah, blah, blah. Once you select a marble, it is not replaced, so it stays out of the bag. All right, so these are different questions. So what's the probability of getting red? 7 out of 15, 7 out of 26. Probability of not green would be the red and the 11, so 18 out of 26. 9 out of 13. Pure green or red, so if you take a green or a red, you win. So it's green or red, so it's 15 out of 26. And then what's the probability of getting a red? The probability of getting red is 7 out of 26. So here's your red, you leave it outside, you come back in the bag. Instead of 7 red, we have 6 red. And what do we want? We want a green. The probability of getting a green is 8 out of. Notice that your total is going to change. And that's your answer. Then you can figure out what the answer is. Uh, 7 out of 26 times. What am I doing? 8 out of 25. I should just simplify it manually. And we're going to press simp enter. 28. The probability of that happening is 28 over 325. So less than 10%. There's a 30% chance of rain on Saturday and a 30% chance of rain on Sunday. What's the probability that it will rain all weekend? Well, the probability of rain, so I'm going to write rain on Saturday times the probability of rain on Sunday. Well, the probability of rain on Saturday is 30%. So remember, we change the percent to a decimal, 0.3. Probability of rain for Sunday is 0.6. If we multiply that, you get 0.18. You change that to a percentage, maybe, depending on the question. You got an 18% chance that's going to rain all weekend, which is not that bad. Maggie flipped a coin 20 times. Here are the results. Which is greater, the experimental probability or theoretical probability of flipping heads? Well, any experiment, so let's go heads. Let's write that. And here's the experiment. I'm going to put X. And here's heads of theoretical. So, in the experiment, how many times did the coin land on heads? Well, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 20. If you think about 4 over 10, or 2 out of 5, and that's a 20%. Sorry, 40%. So, in her experiment, 40% of the time, the coin landed on heads. Right. Theoretically, what's the probability of landing on heads? It's a half. Right? So, a half would be 50%. So we were expecting, so before the experiment, we could have said, well, the probability of getting heads is 1.5, which is 50%. So out of 50%, if you throw the coin 20 times, I'm going to expect the coin to land on heads 10 times. Is that what happened in the experiment? No. It landed on heads 8 times. So how did they compare? Well, the experimental probability was a little bit less, right? Compared to the theoretical we were expecting, what we predicted. Okay, so you can use all that to explain. 35 cars in the parking lot, 12 black, 10 silver, 5 blue, 5 white, 3 green god. 2 cars are selected at random. What's the probability both of them are black? Well, the probability of getting a black car is 10, 12, right? 12 out of 35. If you go back, so here's your black car. I'm going to park it outside. I'm going to go back and get another black car. Well, you'll notice that we don't have 12 anymore. We have 11. And what's the total? Not 35, but 34. And you guys can multiply that up. Okay. There are 14 pieces of candy in the bag. 4 broken. What's the probability of reaching into the bag and pulling a non-broken? So 4 broken candies, which means 10 are, I guess I'm calling normal, and 14 total candies, right? So if I know 4 are broken, the other 10 are not. So what's the probability of putting my hand in the bag and getting something that's non-broken? I guess they call it non-broken. Something that's not broken would be 10 out of 14 or 5 out of 7. A survey was taken on student ice colors. The results are shown on the table. It's experimental probability that a student has hazel eye colors. Well, first of all, how many kids did we ask? 58, 60, 60, and 20. There were 80 total in our experiment. So what's the probability that somebody had hazel? Was 8 out of 80. Simplify, 1 out of 10. 1 out of every 10 kids had hazel eye color. So if we get 400 more kids to survey about their eye colors, how many of them would you expect them to have hazel eye color? So we can use the results here of our little experiment to predict how large a population is going to behave. So 1/10 times 400 is just 40. So if we check the eyes of the next 400 kids, we expect 40 of them to have hazel eyes. Maria flips the coin 20 times. The coin lands on tails 9 times. According to the theoretical probability, how many more times would Maria have expected to land? Well, theoretically, before she flipped the coins, the probability of landing on tails, we know it's half. We multiply that by 20, so she was expecting 10 of them to land on tails. Is that what happened? No. 9 times happened. So again, we can use that and use that information to answer the question. So one more time, she expected to land on tails. Why is she expecting 10? She got 9. Marvin has 20 marbles. Okay. What's the probability she will pull 3 clear marbles out of the bag in a row if he does not replace them? Once you take the marble out, it does not go back. So probability of getting a clear, well, we know that there are 8 clear right here out of 20 in the first try. So here's your clear marble, number 1. Go back in the bag to get another clear. There's no 8 clears anymore. We have 7 clears out of 19. So here's your second clear marble. Then finally go back and you take your third clear marble. There was 6 of them. So you have a 6 out of 18 chance. And you guys can multiply the rest to find the answer. There's a 0.05 chance that we will have an earthquake. What's the probability that we will not have an earthquake? Well, if you're more comfortable changing to percent, you can change that to percent. Move the decimal 2 over. 0.05 is 5%. So there's a 5% chance of earthquake, which means the chance of not having an earthquake as a complement is 95%. So if you chose to change it to percent, it would have been not a problem, or even a fraction. 80% of all California drivers wear seatbelts. If 4 drivers are pulled over, what's the probability that all 4 will be wearing their seatbelts? So not everybody wears a seatbelt. So the probability of the guy, the first person wearing a seatbelt, and again, 80%. So you can change this to 0.8 if you like, or you can change this to 4 out of 5, whichever one you want to work with. So probability the first driver is wearing a seatbelt is 4 out of 5. Probability the second driver wearing a seatbelt is also 4 out of 5. Third, 4 out of 5, and fourth, 4 out of 5. So what do we have here? 4 times 4, which is 256. And at the bottom, 5 times 5 times 5 times 625. 625. So you can look at your multiple choice. Okay, if you need to change that to a decimal or a percent, go ahead and do it. Okay. Kim wants to roll a die 300 times. How many times would you expect it to land on 4 or 5? So the probability of landing on 4 or 5. First of all, let's calculate that. 4 or 5 is 2 out of 6, or 1/3. So I'm going to take that 1/3 and multiply that by 300, and that. So probability. How many times do we expect it to land on 4 or 5? About 100 times. How many times would you expect it to land on 1? Probability of 1 is 1 out of 6. So take that, multiply by 300, and we get 50. So out of 300 times, 50 times we expect it to land on 1. Expect. Once a cube is taken, it is replaced. So you take a cube, you put it back. So what's the probability of getting 2 yellows? Well, it would be 5 out of 15. And you look at the marble, you put it back in the bag. So the chance of getting your second marble is also 5 out of 15. So that's 1/3 times 1/3, or 1/9. Not blue and blue. Again, something that's not blue would be the 2 red, the 5 yellow, and the 5 green. So that's 12 out of 15. And then you look at the marble, you put it back, and now you want to get a blue marble, which is 3 out of 15. And we can do all this fun stuff. Divided by 3 is 4, 5. So 4 out of 25 chance of that happening. 5 science, 8 math, 2 social studies textbook at top of the shelf. If you pick 2, what's the probability that both are science books? Okay, so what's the probability of getting a science book in the first try? Well, there's how many books there's. So 5 science book out of a total of 15. So you have a 5 out of 15 chance of that happening. So you take your science, you put it over here, go back. There is no 4 science, there's 5 science. There's 4 science now, so it's a 4 out of 14 chance of that happening. Multiply, find your answer. Which number does represent the probability of an event happening? So one of these actually represents the probability of something happening. So remember I told you, all our percentage, our numbers are going to go from 0 to 100% in either percent format, decimal format, or even fraction format. Okay, so here we have 50%, here we have 0.5, and here we have half. So 9 over 5 is definitely more than 100%, so that's not it. 1.34 is more. 250 is more, right? It's outside this parameter here. We want any number from 0 to 100, either in fraction, decimal, or percent format, and 0.004 is actually right here, right? Very close to 0. So it's a very tiny chance. So this actually represents the percent of something happening. Tim traveled early to work 2 times in the last 10 days. So he was early, and then we're going to write early 2 times, and then which means he was late 8. It should be 8 lates. A total of 10 times he went to work. What's the probability he will be early to work tomorrow? Well, based on that, the probability that it's going to be early tomorrow is going to be 2 out of 10, or 1 out of 5, or 20%. Based on the experiment, what's the probability the next row will be a 3? Well, based on the experiment, let's add this up first. 11 and 9 is 20, plus 20 is 40, so there's 50 times. So total here, I'm going to total 50 times. So, and we want the next row will be a 3 based on the experiment. So based on this, the probability of getting a landing on 3 would be 4. So P of 3 would be 4 out of 50, or 2 out of 25. Sam rolls the dice 600 times. How many times should she expect a 3? Well, take that 2 out of 25 and multiply it by 600 and make a prediction. So 2 out of 25 times 600 equals, so 48 times. The next 600 times we would expect to land on 3. Okay. 18. How many different outcomes are there when you roll a die? When you roll a die, there's 2 outcomes. When you toss a coin, there's 2 outcomes. And you roll another die, it's another, oops, sorry, go back. When you roll a die, 6 outcomes. When you toss a coin, it's 2. And you roll another die, 6. So how many different outcomes can we have? What is this? That's 72. 72 different outcomes. Okay, so this is the fundamental counting principle, right? 19. How many different pizzas can you create based on the choices given? So we have a choice of 2 thick, a crust, 2 choices, so it's 2. Cheese, we have 2 choices, regular or extra. Toppings, pepperoni, olive, sausage or chicken. That's meats, I guess. 3 choices. And then vegetables, olives, mushrooms, onions. 3 choices there. So how many different pizzas can we make out of this? So it would be 36. Okay, Sam spun the spinner 80 times. It landed on green 25 times. So compare the theoretical probability and experimental probability on landing on green. Well, let's do the theoretical. The theoretical, but don't spin it, don't do any experiment. The theoretical landing on green. Well, there's 2 greens. This is green and this is green. 2 out of 4 or a half. Right? So the theoretical is half. So if she's going to spin it 80 times, we would expect 40 to land on green. Okay. Now, the experimental green, what did she get? She spun it 80 times, and how many did she get green? It says get green 25 times. So now you can compare the results. We were expecting 40, but in the experiment, we only got 25. There's no reason why. Okay, it just didn't show up. Right? Green just didn't show up as expected, as theoretically expected, right? Okay, and there's your comparison. 21, at the beginning of the marking period, 78 students selected art, 65 dance, 54 film. It's probably the next student will select film. Well, the next kid who walks in right now to make his choice, that's going to be film, is going to be 54 out of whatever that is. 78 plus 65 plus 54, 197. Okay, and that's that.